And so we can now talk about the two-way if statement. The two-way if statement comes into the Boolean expression, and if it's true, it does one thing. If it's false, it does another, and then the code comes back after the if statements happened. And so, for example, if the radius is greater than 0, they print the area like we did up above, but else it's going to tell the user, hey, that was the wrong input. So again, the if statement and the directional of the if statements allow us to react, and it allows the computer to change what it's doing based off of input and output. And so our programs no longer just rely on straight computations, but they can rely on adaptability to the inputs. And the input doesn't necessarily need to be the user. It could be what's in a text file. It could be what's coming down any source of input to the computer. Right now, we're typing because that lets us see how our programs work. Now, we can do multiple if-else statements. And so here is something that looks at the score that you enter numerically, and then it prints out an A, B, C, D, or F. And so here, if the score is greater than or equal to 90, it'll print A, else it'll do another if statement. And if it's greater than 80, it'll print B. Now, it's greater than 80 but less than 90 because it already failed this if statement. And notice how the indentation keeps going in. And so this is called a nested if set of if statements. There are two ways to write these. You can do an if, else if. This works nicely and shows the indentation, but this can get deep and confusing. This if, else if is a little bit neater, and it keeps everything lined up on the left-hand side. They're logically equivalent. The computer will compare the first thing. If it's false, it'll do the next comparison. If that's false, do the next comparison. The same thing happens here. If will compare, else it will do this comparison. Else it'll do this comparison. So it still spills down. In fact, looking at the flowchart for it, it would look like this for all of these. Comes in, and if this is false, it does the next if statement. If it's true, it exits through. And so the nesting of the statements represents the nesting of the logic and the flow of the computer. And if we follow reading those statements, it is following the indentations of these things. Now, notice the else will always go back to the most recent if. So even if you get your indentation wrong, this if and this else are linked. This else is not connected to the one that it's indented to, because Java compiles the else statement to the previous if. So it's easier to read if you line up your if and your else statements so that they have the same indentation. And if we look at the preceding statement here, so if we go through this code here, this if statement locks these two things together. So if I is greater than j, which is false, it pops down and does here. So if we want this else to be locked to this if, we lock away this other if inside of the braces. And we can kind of think of this as what we're going to find out is some things are local and global. And every time you set a set of braces up, you're containing a set of code that is at a different level than the code before those braces. So this if statement here and this else statement are outside of these braces. and what's inside of the braces is a lower level. So again, if you're trying to get this else statement to match this if statement, then you need to put braces on this indented if so that this else doesn't see what's inside those braces. It looks back up. And so indentation doesn't control how Java compiles the if and else pairs, but the visibility of things within code braces will. And this is going to become really important as we develop other ways of making loops or other statements. What variables and how the compiler can access other things really depends on what we can think of it as sitting on levels. And this braced system is on a level that's below what this outer if and this else can see. If we put a semicolon at the end of the if statement, it ends this. And this is a common error. We're used to putting semicolons at the end of all of our statements, but because if is making a decision and needs to link back to its braces, the semicolon will break it. And this can be hard to see sometimes in your code. And like the book does say, if you're putting your next line bracing, this happens often. That's why I like a if radius greater than or equal to 0 and put my brace here. It keeps me from making this error. My mouse is doing lots of pop-ups, I'm sorry. So if a number is divisible by 2, so if the remainder from dividing a number by 2 equals 0, then it's going to be an even value. Else, it's not going to be even. So we could set a Boolean based off of this if statement, but we can also use the Boolean evaluation of number mod 2 equals 0. So instead of using a if statement to set up a Boolean, use the Boolean statement itself to determine true or false. Now here, if even is true, it'll print it as even. But if up above here we set Boolean to be true or false, if even is a Boolean value, we don't need to compare to see if it's true, because Booleans will return a true or false. So we can ask ourselves, is this thing true or false? So when we're using Boolean values, what we want to be able to do is we want this even to be true or false. We don't need to compare it to true or false, because if is looking for a true or false. So it's very important with Boolean values that they themselves can be a quick test, as long as we make sure that we keep track of their true or false, their true or false nature. And so what we're going to do is we're going to look at a subtraction quiz, which is another listing in the book in the next video slot.